Okay, hello everyone. Welcome to the meeting of the Six-Law Working Group. Please make sure that you are in the right room. My name is Carlos Gomez. The other chair is Shweta Bandari. She is remote today. Our responsible AD is Eric Binker. He's here with us. And yeah, we still need to find some minute taker or minute takers for the session.
Sorry, Luigi. It's very, very low. One seems
Okay.
to work. Maybe just speak up a little bit, Carlos. Thank you.
Okay, thank you. Is it better now? Thank you. Okay, so yeah, we need to find some minute taker. Is there anyone who would like to volunteer? Luigi? Okay, thank you. Anyway, yeah, recall that we are using HedgeDoc as the tool for taking minutes. So um, in addition to Luigi, if you want, feel free to join and contribute to this collaborative process of taking minutes. You can find the link at the end of the slide. So as in the last few IETF meetings, there are also some meeting tips for this one. For in-person participants, please make sure that you sign into the session by using Miteco. You may, for instance, use the on-site tool, which is available from the data tracker agenda. And recall that you need to use Miteco to join the queue because there's a single unified queue, and blue sheets are automatically generated from Miteco. For remote participants, just keep your audio and video off unless you are presenting something. So this is the Notewell. Perhaps you have already seen it several times this week. But anyway, recall that this is a reminder of IETF policies which are in effect on a number of important topics, such as patents or code of conduct. So please make sure that you have read it. Okay, so this is the agenda proposed for today. The first presentation is the usual chair's introduction, um, which is currently in progress, and this will be followed by a presentation by Pascal on an update on the IPv6 ND prefix registration draft. By the way, it should already be 05 on the slide because it was updated a couple of days ago. Then this will be followed by Luigi, who will present the path-aware semantic addressing for LLNs and also the companion reliability document, and then also the generic address assignment option for 6LoWPAN ND. And then this will be followed by a presentation, in this case by myself, on the transmission of SHIC compressed packets over 15.4 networks. And after that, Yongwan will present the update of the transmission of IPv6 packets over short range optical wireless communication. After that, we'll have a couple of items after discussion with our AD. We thought it would be a good idea to have a little bit of house cleaning of some details about the working group. And we first will have some short discussion on milestones. We remove some old milestones, and we would like to add milestones for the current working group documents. And then also we believe it would be a good moment to revisit the charter since it has been published since, well, for 11 years already. And nevertheless, we have minor suggestions, but anyway, probably it's good to have a look. So then this leads to a total of 80 minutes of allocated time out of 90 minutes for the whole session. So as you can see, the agenda is a little bit packed. Other than that, is there any comment, any point on the agenda? Okay, so then this is the report about the current working group documents and the status of them. So the first document is still the IPv6 and the multicast address listener subscription, which has been in the RFC editor queue for a while now. Then the next two documents, path-aware semantic addressing for LLNs, the base document, and IPv6 and the prefix registration, they are quite advanced. We received early reviews, two early reviews actually for each one of these two documents, and the documents have been updated as a result. And yeah, probably the documents are getting very close to possibly working group last call, which is something we'll discuss later today. Then the next document is the transmission of SHIC compressed packets over 15.4 networks, which has been updated and will be presented later as well. After that, there's the transmission of IPv6 packets over short-range optical wireless communications, which has also been updated and will be presented. And finally, we have a new working group document since the last IETF, which is the generic address assignment option for 6LoWPAN-ND, which is a bit related with the PASA effort. So is there any comment or question on the working group documents? Okay, so if there is no questions, then we can proceed to the next presentation, which will be given by Pascal.
Ready when you are.
Yeah.
Okay, so this is Pascal Tubert, and yes, next slide, please. We are looking at the latest member of a big family, which is a set of extensions that we've done. Sorry, I need to be closer than that. Okay. Oh, it's impressive. Yeah, so this is a big family of RFCs basically that were proposed, done in this working group to enable a proactive registration of resources by the nodes to their routers. By proactive, I mean that traditional ND does not require the router to know in advance all the addresses that are in the network. And so what really happens is when somebody needs to know something, he has to cry out loud, broadcast, or something like that to get the information he needs. That's the general family of reactive protocols. As opposed to that, what we've done in 6LoWPAN was to enable the host to declare their resources to their routers proactively, meaning that the routers have to store it. And that's more in a way that traditional routing protocols operate, like OSPF or BGP. You proactively announce your resources to the routers. So after that, they know how to handle things. So that's basically what we've been doing over those years for the ND extension in 6LoW. And as Carl has just mentioned, the multicast registration that we've done mostly for the use of the WISN Alliance is now in the RFC editor queue. And it appeared that there was one child missing in that big family. That was the capability for the host to announce prefixes that you would get from any manner, I mean, from DHCP, from provisioning, etc., announce them to the router. And the idea was to retain the two big values that we have found for the addresses and the multicast, anycast addresses as well, which is, on the one hand, the protocol is agnostic to the way the routers are going to use the information, meaning the routers could be using any multicast protocol. In the case of multicast, they could be using any routing protocol between routers. The way the host talks to the router with neighbor discovery in general is completely abstract for that. So the traditional ND and those ND extensions retain that huge property, making the host completely agnostic to the way the network is operated. In the same fashion, the routers don't have to know in which way the host obtained the resources that is declaring. For instance, there are some networks where the hosts are virtual machines and they are provisioned by external systems. And the routers don't have to know that. The addresses are just declared, or the prefixes are just declared to the router. Same fashion, now there is work, well-advanced work on how hosts could get prefixes delegated for their own use. And well, this is an easy way for the host to declare those prefixes to the router using exactly the same methods that we've been using for addresses and multicast and anycast addresses as well. So there we go. Next slide, please. So as this says, one of the two draft multicast one is in the RFC editor queue, and well, the other has been very stable. That's the least we can say. And then we got those two reviews, in particular, many thanks to Dave Thaler, because he gave a thorough review of the document. There was no major change, but a lot of editorial. It's not surprising there is no major change because the methods are pretty much exactly the same that we know well and that were widely implemented for addresses. So it's the same exactly methodologies being used. So it's no wonder that there's no huge complexity to be found. There was one interesting question from Dave that was, hey, you're doing something specific for multicast and unicast addresses versus what you do for anycast addresses, from unicast addresses, I'm sorry. Why do you have just multicast and not maybe multicast? And why do you have, I'm sorry, prefixes and not specifically multicast prefixes or unicast prefixes as well in what you're announcing? So we never saw a need for announcing multicast prefixes. So that's why there is nothing done. But the question is open if somebody has a use case or finds interest in being more specific than just saying it's a prefix, then it's a good time to let us know because that could impact this document. In particular, we don't have so many bits to be used for describing what we are doing. It's just 2 bits for values. And the 4 values basically say unicast address, multicast address, prefix. And this draft is the one that's declaring prefix. So if we need to be more specific on whether the prefix is unicast, which is our expectation, or if it's something different, then we would need to know now because that would be a big impact. And that's pretty much what I had to say. So do we have any question? Well.
Okay, so any questions from the room or remote?
Yes, Bob Hinden. So I think the first draft, I mean, I've looked at this a little bit because someone pointed it out to me, but this seems like an awfully big step for neighbor discovery to start doing this kind of prefix registration. I mean, we have DHCP already. I think my personal opinion is that this probably needs some broader review than just here. And whether the larger community wants something like this or how important this use case is, I really can't judge, but I think that at least I have some concern.
Okay, I need first to answer the DHCP point. There is a huge confusion here. DHCP is the way the host will get the prefix, and this is how the host will tell the router that it has this prefix. Otherwise, you need a bridge between DHCP and the routing system, which exists in implementations. Like if your DHCP server happens to be your router, now in the code somewhere there can be some magic which makes it so that the DHCP code will write something in your routing table on the same box or something, or through some proprietary messaging system. But otherwise, you've got this gap. DHCP is a server, right? It can reside in the router. Right. It can reside anywhere else in the internet. You ask from that server, hey, I want this prefix. Now, the problem is you live in a routed system like your cloud, and you have to let it know that you have this prefix, the packets for that prefix needs to be done for you. So either the DHCP server tells the routing or you tell the routing. So this is a way that you tell the routing, basically. But it's not DHCP. This is not allocating the prefixes at all, right? This is the host a protocol independent way. You don't know what the routing protocol is, but it will use those prefixes. But this is a way for the host to basically tell Mr. Router, I was given this prefix, please give me the packets.
Well, so at least, I mean, I didn't study the draft in detail, but I obviously didn't understand that. So okay. I suspect there are other people who will be confused as well.
Okay, it's a prefix registration, right? You're registering your prefixes, and it's really said the goal is to be completely independent between the way you get the prefix, which could be from some provisioning system or DHCP, and what the routers do with that prefix, which is maybe use it in BGP or something. You basically ND has this very huge property to be agnostic on both those things. Even traditional ND has that property.
I think the issue is that we have that same problem in other DHCP scenarios, and that sort of needs to be fixed regardless, even for networks that are not using AROs or prefix registration options, right? So I think, as you point out, yeah, there's no sort of
Bridge.
there's no RFC that explains how you're supposed to do this, but there's a lot of RFCs that say if you do this, you do it this way, and I think there's there's enough industry, sort of enough body of work in the industry that this is kind of a thing, right? So for example, there's a specification about how DHPV6 relays are supposed to behave in this case, and how they're supposed to do root injection and so on. So I think, yeah, as you point out, it's not how the prefix is distributed, but in general, using PD on different types of networks requires that prefix be distributed. And I don't know that this is the only or best way, right?
I'm not saying it is, right? I'm just saying, okay, let's look at why we did the multicast thing in the first place. So I was in this Wyson Alliance meeting, and they basically did unicast to start with, and after that, at some point, they tried to go to a meeple, which is a REPL for multicast, if you like. Not really, but that's kind of what it is. And they realized it doesn't work for them. So they said, hey, we want something for multicast, but at the same time, our hosts are really, really small and they are sleeping all the time, etc. We can't afford to implement a real HMP, a real protocol for multicast separate from what we already do for unicast. And so I told them, well, why don't we use the exact same thinking for registering multicast address as we did for unicast? And basically the idea is you have some code which can be very narrow, which can be very compressed, and you want this additional feature at minimum change in what you're already doing or the way you're already thinking things. For a use case like this, the minimal cost, the minimal footprint of code, etc., is to basically behave the exact same way when you're doing addresses and when you're doing prefixes. Like you want this sensor now to own a small prefix or whatever size. This is not discussed really. Well, that's a way for this sensor to tell the routers, hey, give me all the packets for this aggregation. I'm not saying it's the only solution in the world for doing this. And all I know is in a world where people are already doing it for unicast, there's something similar for multicast, and now it's only normal that they also want the same pretty much code to run for prefixes. Where it's going to be used, I have no idea. It's just one method for doing it. Now, another value for this method is that with RFC 8928, I guess, there is a way for unicast addresses to be kind of validated. Ownership can be proven. Once you've declared it to the network once, it belongs to you and you can prove it later without having any PKI or what. So it's some kind of proof of ownership that exists there. With prefixes, there would be a way for the DHCP server, for instance, to hand off this proof of ownership. Meaning that when you announce a prefix, and I'm saying DHCP, but again, it could be any provisioning system. When after that, the host announces the prefix to the router can check using this exact same method, which is already in RFC, that the host that announces the prefix is really the one to which DHCP has delegated it, which is some value as well. So I'm not saying it's the only way. I'm saying all those things are available with this simple RFC.
That actually seems backwards. In prefix delegation, it's not the host that announces the prefix to the network. It's the network that delegates the prefix to the host. So the router is actually
it's the server that delegates the prefix, and then there is a need for both the host and the routers to know about this.
Right, but the router is in control of the
server
of
is.
Yes, but the router is controlling of whether the host actually gets the packets.
Yes. So that's why the router needs to trust the host if the host is the source of information. If the DHCP server is the source of information, it needs to trust the DHCP server.
Right. So for
or
PD,
AAA or whatever else.
For PD, it is the server that's the authoritative source, not the host.
Yes, and that's why there is a need of a proof from which we do have actually. So it doesn't. It's okay.
Eric Vink, individual contributor on this one. Did you consider sending a route advertisement with a route information option to do the same? You understand we talked about six flow router.
Putting it in an array. Oh, long time ago, this work started with arrays, and then we realized really it's host talking, and people were a lot more comfortable with host using NAs as opposed to arrays.
But in this case,
or NS, actually.
the host, of course, it's a host. It's not a big fat router, of course. But if it's receiving addresses for a prefix which is not on link and forward it further to a VM or whatever, it's actually a router.
It is,
So
if it is effectively forwarding them, if all the prefix is locally delivered. So you don't know. I mean, the host is pretty much free to be a router if he wants to, but at that point of time, with this protocol, it shows as a host. Now, it could be nesting VMs and be a router in memory. It could be having devices. I mean, that's the use cases we've heard at 6man. The devices are behind or something. What the host, quote unquote, does, how we got the prefix, etc., is totally agnostic. The routers don't have to have a clue about this.
agreed. But I mean, this thing will work, right? Your protocol will work. I don't.
It would. It's just a matter of messaging. Do you want
That's
to show
why
us
you
a
don't use
host
an
or-
array with a route information option, because snack routers, for instance, kind of similar, right? Do the same. Actually, they send array with a route information option.
So we started with NSNA because that's what we're doing for all the other types of things. We're just extending slightly the code base that does that. Now, should we be seen as routers when we are doing this? Sometimes yes, sometimes no. Do we need to be seen as a router? What's the value? I don't know. I'm asking you. Because you're claiming I'm a router when you're doing this.
But then the router, I mean, it will install a route to the prefix with the next stop being the address of the host, right? So
yes, it will.
So it'd be an entry in the route information base.
Yes, that's the goal.
And the forwarding it. So
that's the goal.
It's basically a router, right? So for the real router, let's say, this machine will be seen as
it's
a router.
agnostic. You don't really say anything, so you can be anything. It could be, yeah.
Okay. Anyway,
it's just you're passing a packet to the host. I mean, that's the whole deal with all those stories, being able to pass packet for a prefix as opposed to for an address. So this belongs to this family, and it still shows as a host. I mean, DHCPPD to a host is the name of one spec we're familiar with, right? It's not saying DHCPPD to routers.
I mean, there's a lot of overlap with Snack, right? And the question is like, why do we need, I think, 2 or 3 protocols to do the same thing, right? And Snack is sort of kind of more general, right? So and it reuses standard types of packets like arrays. So there's no need to define anything new. And so that's the question, I think, kind of duplication with existing protocols. And, you know, obviously a lot of the work in this group is for very specific use cases that, you know, where power is, basically requires making different trade-offs. But this seems like very, very similar, and basically having duplicate protocols for the same thing.
Yes, I did not look at Snack for a while. When we started at the first meeting or second meeting, looking at what the work was at the time, I mean, this was also a missing link in the Snack solution. The Snack document were not explicit at the time, saying how this prefix will be exposed by one routers to the rest of the fabric, of the rest of the routers at home. And also whether the prefix that's being exposed is local, is on which side of that particular router. I mean, the side of all the other routers, like inside home, or maybe in the bedroom only on the other side of this router.
Eric Coyne, I think to that latter point, doesn't that just affect which interfaces you advertise on? To everybody else's point, I think it feels more natural that this should be an array, and it feels also additionally weird that we have one working group that's recommending snack array, and here this one is trying to do something different. So it kind of muddies the NDP waters conceptually, I think.
Okay.
So because you're talking about advertising that you have a prefix, regardless of the allocation method of that prefix,
True.
right? And so that's not necessarily all that dissimilar from Snack.
Okay. Like I said last time I looked at Snack, that was the piece that they were missing actually in their overall solution, but that was the very beginning of the working group. So I don't know what happened to that piece yet. But I actually presented that to Snack at their very beginning, saying, hey, we can do this to solve that particular missing link that you have.
But the thing is that what Snack does works with existing hosts that are unmodified, because it uses existing protocols. And I think they have fixed this problem now. If you're a snack router, even if you get a prefix delegated from the network, you do send an RIO on a northbound link, let's say, and that's how things on that link know about you. So maybe this is just sort of a working group race condition where maybe we should just like make sure that we don't publish two things around the same time that kind of do similar things.
So Eric Ving, this time with my idiot, may I suggest, Pascal, that if you think that the way Snack is doing it, because it's doing basically normal thing, right? Nothing specific, does not apply to this use case you have in mind. You describe why sending a route advertisement with a route information option does not work in some specific use cases that you need this protocol. Right.
Okay, and I have to look at the way it's done because this is pretty much okay. First, the RIO doesn't provide the information that we have in this option, like lifetime and all those things. It's just saying route through me. So I don't know exactly how it's modified for Snack, so I can't answer. But okay.
Okay. Anyway, we will not solve the problem here. What I suggest, Pascal, is that you look about how Snack did it. Snack changed no protocol at all, right? You look about how Snack is doing it, and you see what is the difference with your proposal here. Okay.
Okay.
If there is something different that
well, if it's
I'm
an
not aware,
array broadcast, then it's already a difference because we do that unicast. We announce to one router using unicast, and that's important. What we're doing because we don't run broadcasts in our networks. So again, I have to see if they did some changes versus that. Okay.
Okay, thank you very much. So yeah, so we have an action point for this document. And yeah, let's see the outcome to see whether there's an actual overlap or maybe it makes sense to have two separate documents from the two different working groups. Okay, so then the next presentation will be by Luigi, actually a set of presentations related with PASA.
So I'm Luigi. I will give a brief update on the PASA document. Since the last meeting, we had a short update. In reality, the revision is all about addressing the residual concerns that Joel had about in his RTGDIR review. Okay, so as usual, we try to go over the document and polish it, catching typos, etc., etc. The main change is about the section reliability consideration, because Joel raised the question of what if we are multi-home and we have several nodes that can give us connectivity outside the PASA domain, right? And yeah, we have a few solutions that we added in the reliability section. The first one is just to use multi-topology. We can have several instances of PASA in the same domain with different routes, which give us redundancy, basically. Okay. The initial idea of PASA was to use the route as a gateway, right? But we can separate these roles. So we can have a route that does the addressing, right? And we can have several nodes that are gateways to outside the PASA domain, right? And this is a different solution, is suitable if you want to do load balancing. You have to be a little bit careful about how you design your and deploy your network, okay? We can use existing solution, the virtual router redundancy protocol as well, in order to have several exit points that basically share the same address, okay? Last resort would be to use a routing protocol, but just to remind you that the PASA, the idea was to not use a fully fledged routing protocol into domain, just use instead the addresses in order to do forwarding operations. So, I mean, if you deploy as well a routing protocol, you're getting rid a little bit of the advantages of PASA, but could be if by any chance you have this need. Okay. And that's it for this one. If you have any comments or question, no, I think we are getting closer to working group last call, but I will come back to this point after Gauss, if you don't mind, because it's
Okay.
an overall thing. Okay. A quick word as well on the reliability document. So basically, if you remember, there is a companion documents that really discuss in depth the reliability issues related to a PASA domain. Okay. Which, by the way, discusses in depth one of the possible solution, the multiple topology solution. Okay. Again, it's been modified as a follow-up of the review that Joel provides us. And yes, we added text about non-volatile memory. This is to be in line with GAO. And added text about multiple PASA routes, and which is also multiple gateway. Okay. And that's it. So just we made basically this second document in line with the first one according to the changes that we made. Okay. And now switch to GAO, unless there are questions or comments on this one. And then we can discuss last call milestone if you wish.
Okay.
I'm asking again slides. Have a look to change the slide back. So, this one. Okay, so the main change of this document since the last meeting, as was already discussed in the working group draft documents status, is the fact that has been accepted as a working group item. And main change as a content is the IANA section, because we had the IANA review. I have to change it again because I received again IANA review, and there are a few things there I have to update. Other than that, seems okay. We are done. But several times there was the observation on the GAO option format, if we really needs all the flags that we allocated. Now, this is the current format, okay? And as you see in the red rectangle, we have a few flags that we allocated. The initial idea was to be in line with the ERO format so that we can easily reuse, copy and paste the flags. But we have a flag for the confirmation. If you remember, this option is just to ask to have to obtain an address or a prefix. Okay. Once we have a proposal, then we use existing machinery. We may use existing machinery as a confirmation that we are using the address or the prefix. Okay, via a registration procedure. Now that flag just is used by the router that assigned the address to say, please confirm that you are using this address. And so we go through the registration procedure. Okay. And this we need to keep order because the registration is optional, so we need to signal. The second part is the F field as defined in the prefix registration document. Okay. and indicates basically if the sender expect the other routers to forward packets, blah blah blah. But well, this is not a decision that we need to do when we ask for something, for a prefix. Is when we are registering the prefix. So please behave like this using the F flag. Okay, so we don't need it, I think, in the Go option. Okay. Then there is the P double bit field is about is this address unicast, multicast, anycast, union, etc., etc. Well, we usually, and there was some discussion here, we don't request a multicast or an anycast address just like that. So I don't go to a router and say, oh, give me whatever anycast address you have available, right? These kind of addresses are used in a totally different way. So looks to me that we not really need to indicate the type of address. We just use this option to ask for unicast addresses, basically. So we have 2 bits less, the 2 flags less to be used. Okay. Then there is the I field, 2 bits again. This is related to the opaque that is in the first line. Okay. As far as I know, the only use that we have today is just the value 0, okay, and which is the default, and then the opaque basically indicates an abstract index related to let's say like a VORF, so or an instance ID. Now, since as far as I know, we don't have any other use, we can consider implicitly that we have the opaque, okay? And if by any reason we want to change it in the future, we can do it by using other flags, okay? So what we have, what we obtain is this. So we have the C bit for confirmation, a P bit just to indicate we want a prefix. We would like to receive a prefix. And then we have the rest is now reserved for future use. And we have the AAF, the address allocation function, okay? 8 bits, 256 values. So we may even ask, do we need 256 possible values to identify an algorithm that is used to distribute addresses? Maybe not. We may shrink this to 4 bits, 16 values, okay? And so we have how much? 12 bits, basically. And no, 10 bits available, reserved for future use. If we want to extend the AAF or get rid of the opaque, we can do it in the future by allocating these flags, basically, right? So I think that at this point, what we should decide, and would like to have feedback from the room, is that is it okay to change the format? It's nothing that is not a revolution. I mean, we are just moving some bits or getting rid of some bits that anyway are not really useful. If yes, which format do you prefer, or we prefer? Is AAF of 4 bits sufficient, or we stick to the 8 bits format? Okay, and that's it. Now, depending on what we choose, has consequences a little bit on the milestone. I can so if we go for a 4 bits AAF, the has impact on PASA, but it's pretty simple. Okay, and so this one PASA can go for working group plus call before the end of the year. For both the choice, GAO, I would like to take the time to be clear in the spec so that there are no, so maybe January, February, something like that. I don't know. We need in both cases a revision. And that's all from my side. If you have comments, feedback.
Okay, any Any comments, questions? There's Lorenzo in the queue.
Why not just reuse an existing packet formatter protocol for this as well? Right. I mean, for example, the draft says, well, DHCP is not efficient from an energy perspective, but there's nothing that says you can't use DHCP to your neighbor router, right?
And this stuff doesn't say you cannot use it or this is bad. There is an alternative, right?
But it is an alternative. This is an address assignment mechanism, no?
Yeah, for a specific use case.
Okay, but we already have an address assignment mechanism.
Yeah, but
that is
this
arbitrary, can work for all use cases. It's a one-off
but
exchange.
if you go in the context of we want something that is low power consumption, then the DHCP is not the best solution.
Why not?
It's certainly a solution. Will work? Yes.
It's
Is the more efficient? Maybe not.
No, it's packet in, packet out, right? It's like it's a 2-packet exchange. Do your DHCP6 with rapid commit, and I don't see how this can be much cheaper than that, right? It's still one RTT, you know?
So there are two things. This came out from the. So.
Oh yes, they will.
So this came out from the PASA document, which is you assign the address in an algorithmic way. You can do it with the DHCP. Yes, it's more efficient doing distributed. In the PASA case, yes. Okay. Anyway, in a certain way, let's go back to PASA. Do we need an algorithmic distribution of the addresses in order to do stateless forwarding? No. Yeah, but
that wasn't the point. What I'm saying is, like, you have a packet format here. You can just use DHCP6 as a packet format. You can ask the question of the same thing that would give you that address, and you can just ask it using the DHCP6 protocol. And you don't have to define a new protocol.
I think this way is still more efficient because you have it directly in the ND protocol. So you, I can look deeper in the question, certainly.
But isn't the efficiency, especially in terms of energy, amortized by the assignment lifetime? So if you have sufficiently long assignment lifetimes, then you don't renew for quite a long time.
Yeah, this is
You
kind
still
of
have to be awake at the
even
same-
in the HCP. In both cases, you have a lifetime.
It's
so
still a 3-packet exchange.
yeah, but the lifetime, assuming you don't look at the handshake part, then the lifetime is the same for the two solutions, right? I mean,
Right.
whether you
So-
have it DHCP or this one, you can set the lifetime.
So
the same.
we're not often super diligent about it, but we do have some guidance, I think, in one of the internet architecture principles about not having two solutions to do the same thing.
Yeah.
In general.
We can agree.
We're not terribly good about sticking to that.
This is
It's not very clear to-
simplistic because you are not looking the context, in my opinion.
No,
but
this
it's
is not
just
very-
my opinion.
This may not be clear to you because Pascal just asked me the same question, and I think what Pascal says is like, well, when you do DHCP, you basically send a packet all the way out of the mesh to the DHCP server. I'm not saying you should or shouldn't do that. What I'm saying is you're defining a packet format to communicate with somebody who has an address for you, and they know that that address is efficiently allocated. I'm suggesting instead of defining a new packet format, use the DHCP6 packet format, which allows you to ask a question and get an answer with a 2-packet exchange.
I see.
And it's got all sorts of stuff already defined. You don't have to define retransmits. You don't have to define any of the semantics. So it's all.
I don't need to redefine that for this one either. Because it's just an option of something existing. It's not a new
If you
thingy.
don't get it, you need to retransmit the request, right? All of that stuff does need to be defined, I would think.
Yes, but
Slightly different question.
Yeah.
I mean, the justification I think I heard is that this will use less energy. But do you have any data on how much less energy? I mean, is the savings justified creating new protocols? Because there's a cost to that too, having specs for doing similar things in different ways in different environments. We gain a lot by using the same things over again. So
No, I don't have figures about the exact energy saving, but
Yes.
this can be added.
So
It's a fair point.
when
Yeah,
we-
yeah,
yeah.
yeah, absolutely. Thank you.
So maybe, yeah, Eskodijk here. I was just wondering, so to clarify, I think the idea was to have just the option, which means you can piggyback on existing traffic, right? So the
Yeah.
idea is there will
Yeah,
be
indeed. Yeah.
6LoWPAN, some sort of ND message being
Mhm.
sent to over one hop basically, and then
Yeah,
you just
exactly.
piggyback this request in there. And I think the idea that's more efficient than having a separate DHCP exchange using a separate message. I'm not sure if the question was of the audience whether to yeah, reuse the DHCP format in this option, which is something you could also do. But
As
maybe
far as
something
I
to
have
consider.
understood, you
Sep-
Lorenzo, correct me if you are suggesting to use the DHCP format in this option
or as
wrong?
a separate message.
or a separate message.
No, for the record, I was saying, use the DHPv6 protocol to the same entity that you would be speaking this. And I didn't, I obviously you do have a point that this exchange may or may not be happening already, right? And the question is like, yes, if you piggyback on that exchange and you send the packets back to back, how much is the savings of like one message versus two messages, and is that worth defining a separate protocol? Really, I think.
Agreed on the question on let's say how much do we save, but in a certain way it sounds a little bit all the optimization, not me, but that has been done about ND and others assignment for low power networks are not useful because at the end of the day we can use DHCPv6. Sounds a little bit like this. I'm wrong. I'm asking clarification on what you are saying. It's just
Yes, if the data
Okay.
don't support, if you do the numbers and the data don't support an improvement, then yes, the improvement or it doesn't support a sufficient improvement that justifies the additional complexity of implementing a different protocol. Yes, it shouldn't be done. I think that's reasonable,
But
right?
the
It's just an
ND
engineering trade-off.
optimization for 6LoWPAN is existing already.
No,
Yeah,
for ND and like address discovery, all of that stuff, that's a different trade-off. Those was all presumably, I don't know the numbers, they were all probably decided at the time. There was a lot of discussion, engineering trade-offs made. I don't pretend to know the history, right? What I'm saying is like looking at this incremental change in isolation, you have basically an option of saying, okay, I can piggyback on an existing message, or I can send another message back to that message and receive the response back to back, and use a protocol that's already defined, which is a code simplification perhaps, and a sort of like just a general protocol simplification. And then the question is like, which one is more efficient? It doesn't matter that it's like a little bit more efficient.
thank you. Now it's
Yeah.
clear.
So yeah, I mean, which format you're using does not matter if you talk to the very much if you talk from the same entity to the same entity. What I'm more concerned with is what the expectation from both entities. Like if the child now has to believe that the parent is a DHCP server, I mean, what kind of services can it expect, right? I mean, right now the parent would just do this and only that. So yes, you could use the DHCP formats, but you could not still expect the parent to be a full-fledged DHCP server. Then you would have to implement some code footprint a lot more than what's needed there, because this is just extending a code footprint. Think again, small devices, right? The code footprint is important. And the expectation that you get about your parent are also important. So if you think it's a DHCP server, you may start asking anything, using any option, etc. But the guy above you will not support any of that. So it's a bit dangerous in my mind to expose to small devices as if they were DHCP servers. So if you start writing, hey, I'm not using this format, I'm using the DHCP file state machine, and you still have to write quite a long document, say, okay, it's using DHCP, but only this. And now I wonder if it's not more work to carve stuff out of DHCPs and just declare what we do here, using ND as we're already doing.
Thank you.
Yeah, I think you'd basically have to say there's no requirement for any node to implement anything else than the IANA option. Yeah, I mean,
to the mic,
Maybe,
maybe,
yeah, the mic.
guys, to the mic. Well, yeah. Thank you.
Okay, any other comments? Okay, thank you. Let's see. Okay, so I'm going to present the last update of the draft entitled Transmission of SHIC compressed packets over IEEE 802.15.4 networks. My co-author is Anna Minaburo. Next, please. So reminder, what is the main goal in this document? On the left, you can see the traditional IPv6 based protocol stack for devices using the 15.4 radio interface. IPv6 is supported by means of 6LoWPAN as the adaptation layer, which provides several things like header compression and fragmentation, among others. And on the right is what we want to do as the main goal in the draft, which is offering an alternative way for header compression, which in this case would be using SHIC, which we expect to offer a greater compression performance because it exploits a priori knowledge of header field values of the packets to be transmitted. Next, please. So on the status of the draft, it was adopted in January last year, and today I'm presenting version 07, which contains several minor updates throughout the document. You may recall that in the last version, 06, we had some quite major update. Basically, we tried to align with several new concepts in the SHIC architecture draft. However, now this time we are waiting a little bit because we know that there are some ongoing discussions around the SHIC architecture, which, however, haven't yet made it into a new update of that draft. So yeah, in this regard, we are a little bit waiting to see the evolution of that. So next, please. So in terms of the structure of the document, here you can see the main updates. We have two new subsections or sections. Next, please. So the first new subsection is 2.3. So this is part of the terminology section. Basically, we want to define a new term, which would be SHIC-low network. And this would be a 6LoW network where SHIC is used for header compression and decompression. The reason is that quite often in the text, we need to refer to the network, but that doesn't mean the whole network, including the internet and devices that don't use header compression and so on. We want to refer to the 6LoWPAN network where SHIC is used for header compression and decompression. And even 6LoWPAN network would be like too broad. So we want to emphasize also that these are devices, or this is a network where SHIC is being used for header compression and decompression. So here you can see on the slide an example, one of the figures that we have in the document. And in red, you can see the SHIC-low network part. So this would include the hosts, 6LRs and 6LBRs, which are involved. And the internet part without header compression and so on remains outside of this. By the way, probably we will also start talking about this draft as the SHIC-low draft. So next, please. So some of the other updates, for instance, in section 3.3 about multiple instance networks, recall that these are the networks where at least some of the nodes use several instances for SHIC header compression and decompression. Here we have basically updated one sentence, which used to be in multiple instance networks. The SHIC header cannot be fully compressed. However, we have introduced this cannot generally be fully compressed because there are some cases where it can actually be fully compressed, as we already presented in the past. There's a reminder on the next slide. So next, please. So that's in the case of mesh under. So in this case, it is possible to fully compress the SHIC header in some scenarios like the one shown here in the example. So imagine that we have the nodes here with the rules for compression and decompression and the instances shown in the legend on the right. And let's focus on the two ones highlighted with red arrows. So here we have two different rules with rule ID 2. And however, one belongs to instance 1, the other one belongs to instance 2. And let's say that node A receives a SHIC compress packet with rule ID 2. Then the question would be, okay, which is the instance I need to use to decompress the packet? So in this case, it would be possible to tell which is the right instance based on who is the actual source of the compression, source of the packet. And yeah, this is because here we are in mesh under. So the source of the packet is present in the mesh header. It's actually its MAC address. So if there's no ambiguity in that regard, then we can actually tell which is the instance that we need to use to decompress the packet. Next, please. There was also some comment that we received from Peter Yi. Many thanks for the comment. This is actually editorial, so there's no technical change. And this is in the security consideration section. There's one paragraph about the pointer-based route over mode that actually it creates a new opportunity, a new way for an attacker to actually attack the network, which is described here. And the improved text is shown at the lowest part of the slide. So it says now that the malicious node might be able to modify the related fields, which are the bit pointer or the address length, to prevent the router from correctly reconstructing the IPv6 destination field of a SHIC compressed IPv6 packet, thus preventing delivery of the packet to its intended destination. So the new words here are highlighted in red, and actually, yeah, basically this is an editorial improvement. Next, please. So there was also in Vancouver, but in the SHIC working group session, there was a question by Bob Moskowitz about the relationship between this document and RFC 7973 and an ether type that had been assigned for IPv6 datagrams using low-pan encapsulation. So yeah, now we have added an informational appendix which describes that 7973 basically is a report that IEEE assigned an ether type for IPv6 datagrams using low-pan encapsulation, which are defined in that document as those which use the dispatch octet as defined in section 5.1 of 4944, subsequently updated by RFC 6282 and actually updated even more by subsequent RFCs. So we explained that this document, the SHIC draft that I'm presenting, we consider that it also uses low-pan encapsulation, as it uses the dispatch octet as it has been described in 7973 and subsequently updated. And this document can also benefit from the mentioned ether type, meaning that if there is some link layer frame where this ether type is present and it signals the presence of an IPv6 datagram using low-pan encapsulation in the payload of the frame, then the payload of the frame could be a SHIC compress packet, and we will be able to tell whether it is SHIC compression or whether it's another compression technique, thanks to the dispatch that it's used in the payload. Next, please. Yeah, so basically as next steps, we plan to continue monitoring and aligning with and perhaps also contributing to the SHIC architecture draft. So as soon as the discussion there stabilizes, we will also continue this effort. And also we need to elaborate on the so-called transition protocol stack. Recall that this is a protocol stack where 6 low-pan header compression is used for compressing IPv6 headers. However, here we would introduce SHIC to compress upper layer protocols like, say, UDP or CoAP. So for instance, we may need to define the SHIC header format that we need to use for that. So next, please. That was everything from my side. I don't know if there may be any comments or questions. Okay, so thanks. So if there is none, then I guess we can proceed with the next presentation.
Yeah, this is Youngwan Choi from Korea. Please move the slides for me. Yeah, this is the second draft of the IPv6 of OWC. Next slide, please. Yeah, the next slide, please. Yeah, this is the table content that actually I have just several of the minor update for this time. The first one is section 5 and the other one is section 8. But there's I bring some issue about that the 6-row-pan capability bit and at the end of this slide. Next slide, please. Yeah, the first update is the section 5 just I modified some figure number 7 and 8, just the kind of that the topology of the connectivity of the with that the OWC devices. First one is the kind of star topology connected with the internet, and the other one is the isolated multiple the network, multi-home network. Next slide, please. Yeah, the next update is there was comment from a comment from the in the previous meeting. Actually, at the time, just they comment the minor update about that the sub registry in the text, but just the two with that just the registry, and the other one, the other change is actually I just put under the reference about the SDHC, but the original reference is the RFC 8725 and 24. So I changed that one. Next slide, please. And in section 8 just references, I just separate them with that normative and the imperative. The next slide, please. This is the location issue about the 6-row-pan capability bit. Actually, Eric in the previous meeting gave us a kind of the question, the why just put that the 47-bit to put the S bit. But actually, I had double check about the RFC 7400 and the INR registry. There's no problem according to them. The S bit okay. According to the registry, there's the blue box is for only visual for the experiment use, and the other, the green box is already reused and they are registered, and the other red box is resolved the vacancy. But we just used it at the end of the 47-bit for S-bit. And I just found another use, the GAO document. Actually, they used that M-bit for 7-bit. Actually, also no problem if the M-bit is so experimental use. The next slide.
Yeah, perhaps,
yeah.
If I may, yeah, on the GAO draft, yeah, we would need to double check if the intention is actually to use the M-bit as experimental. Perhaps that was not intended. Do I have? Perhaps I don't know if Luigi. Do I have it right? Because the first bits which are reserved in on the slide on the left are defined in RFC 7400 as only intended for experimental uses. So that means that if that's not the case, maybe the M bit in the GAL draft may need to be a different bit. Okay, yeah, well, we can continue discussing.
So Luigi, I received exactly the same IANA review, if you wish. I proposed some bits there. Maybe I did a sloppy job in the sense that I went to the IANA site, I looked what was free. For me, was logical to continue in the allocation. As I put it there, right? IANA said, maybe not. But I mean, moving the bits for me is not an issue whatsoever. It's part of what I said before. I have to review again the IANA section.
Okay.
So actually, they proposed one position. I don't remember out top of my head which one, but
I think it was bit 16, which is the opposite to the one we're intending to use here, the S bit. Yeah.
well, position doesn't matter to me.
Yeah, no matter.
As long as we don't collide. Yeah.
And next slide, please. Actually, this is the at the end of the slides. Actually, the next update, I just put a kind of TBD for section 7 security consideration, but I invite this another contributors, Monan Choi actually is he beside me, and according his further contribution in the left side and right side there, just new ID there, just he put some kind of content here. According to his further contribution, some of his content will be incorporated in the next update. And all the contributed, his draft will not keep update. Maybe it will be expired. That's all. Thank you. And next slide. Yeah, that's all this presentation. And any question and comment?
Yeah, there is Anne entered the queue.
Hi, Ann Krieger, U.S. Department of Defense. I'm Vice Chair of IEEE 802.15. And so we're going to take this draft. I've already asked the task group chair of .7, who does optical wireless communication, to look at it. And we are meeting next week, so we hope to have some comments for you.
Yeah.
Thank you.
Great, wonderful.
Thank you.
Eric Vink, a question for you, Anne. Do you expect a liaison statement, or do you want to have one? Well, fair enough. Hey, we are ready to. I mean, the chair will be happy to make one, right? So.
Okay.
Yeah. Eskodijk here. A quick question. So I was looking into that SHIC compression that you mentioned. So it looks like the compression is optional used. So does that mean we maybe have to add for the other side that the decompression is mandatory to support? Because I think that is maybe good to mention as well. Then. Yeah. Unless maybe it's, I don't know if that's based on capability negotiation. So if one side discovers that the other side does not support SHIC, then it's not going to use the compression, for example.
Yeah, that's a good comment. I think actually I have planned to kind of which one is optional, which one is mandatory. Actually, in this draft, firstly, the 6-LoWPAN head compression is main in the mandatory, but I put the optional compression, the HGACC. Actually, the 15.4 also have the two options. Another, they basically use that the 6-LoWPAN has compression, but the other one optionally that they use that SDFC. The same. Just we are going to put some, the content for that. How to organize to kind of the compression, the method. Yeah.
Yeah, okay,
further.
still to be updated.
Yeah.
Yeah. And one other question, maybe just someone could clarify that. So you define in the draft this chic capability bit. So should that not be in maybe some other draft that defines chic, or maybe it was forgotten there, or maybe you know why it's not elsewhere defined? Seems like a logical thing for example, a basic chic RFC or draft to define.
Yeah, I think it makes sense because something like this might be used perhaps over several possible different lower layer technologies. So it might be not specific to uh, visible light communication. So
Yep.
yeah, we may need to double think about that because maybe some sort of generic um, specification for that might make sense.
Yeah, if there is still a draft in progress, which I don't know actually, but if there is not anymore, then it makes sense to just have it in this document, because you just need a document to define that bit with a possibly generic function. So, but yeah, just this as a comment.
Yeah, yeah, thanks. It's a good comment. Yeah, thank you.
Ian Krieger, to answer your question about liaison statements, I will talk to the 802 representative to IEEE and ask if we should just post to the mailing list or we need a liaison statement.
Yeah.
So we'll figure that out. Thank you.
Okay, any other comments on this draft? Okay, thank you.
Yeah, thank you.
Okay, so now we can move to the discussion about milestones. So, yeah, as mentioned before, basically we have been trying to do some house cleaning. So we removed some old milestones and now we try to create new milestones for the current working group documents. Basically, we would like to have some estimate on when the documents could be ready for submission to the ISG. Of course, I'd like to emphasize that this is an estimate. So perhaps for whatever reason, we may get a bit delayed or some things may be completed earlier. But at least this would give some useful information to anyone who might want to check which is the status of the documents and when they might be actually getting ready. So we contacted the authors of the different working group documents and have some initial proposals as milestones. So here on the slide, you can see the date, the milestone, and the associated document for each one of the current working group documents, which are not yet submitted to the ISG. And yeah, so for the first two documents, yeah, we had like the impression that they were quite advanced already. So we received those couple of early reviews and the documents had been updated after that. Perhaps not sure if after the discussions today, there might be some more time for review. Yeah, Pascal?
Yes, this is Pascal Thubert. So I've been looking at the proposal that I just heard. And I think that the justification for continuing this work is exactly the same as we did for address registrations. Like, this is a simple mechanism by a host using unicast talking to routers, and the routers manage whether they want or not that this thing happens. What is in Slack and basically using arrays is again a multicast way of doing this. And there is all a finite state machine that goes with it, which puts the complexity back into the device, which is exactly what we don't want, right? We want the device to be very simple, and the routers to do all the complicated things, and we don't want any broadcast on the network. So this is why we went to 6LoWPAN-ND when we did, and this is why we're doing this way as well. Now, on the way, I also look at SNAC, and there is no proof that you own the prefix that you claim. For us, on the other hand, it was very important to prove that we own the things that we claim. So we'll really look at different problem space. and we can't afford to have everything which is in the SNAC document implemented in our devices. That doesn't fly. But I just looked to make sure I was not. That was my knee jerk. I said broadcast is probably the reason why. And coming with the broadcast, there's also all the fine state machine that has to handle the relationship between the routers, which we don't do, right? We want a very, very simple. The code in the device is very, very, very simple.
Yeah, let me join the queue. Sorry. I mean, I think there ought to be a slightly higher bar from like, oh, this is completely different from other networks to explain why you're reinventing a lot of wheels here. I mean, it's sort of, this is more, I guess, a question maybe for the AD, but I think, I mean, it's worth noting that arrays don't have to be multicast, right? And yeah, they could be unicasted, right? So I think, and you're also like maybe better off trying to fix SNAC for your use case than like basically forking the protocol stack, right? Because you're essentially, you have your own version of ND, you have your own version of prefix delegation, you have your own version of address assignment, right? You're building all sorts of separate stuff. Now, if somebody that has a classic v6 host wants to implement this stuff, they have to implement a boatload of stuff, and it's not really clear how much better this custom design stuff is than the protocols we have. And it's also not clear whether the protocols we have could be made slightly better for this use case than they are today, right? For example, like just unicast arrays are kind of obvious and something that can be done pretty trivially, right? So,
Pascal, yes, same thing through my mind. I mean, I wondered exactly the same question. I was looking at, same thing. What do you expect from the devices? What kind of implementations? So if you say, hey, your small device has to implement SNAC and just say unicast, I mean, it doesn't change the fact that there is this big implementation that has to be done in the device. We are back to the question about the HCP. We'll give you the hand, but it's not just using the framing. I mean, using an array or an NA. That was a discussion we had that in my very first slides on this draft, at the beginning of this work, it was an array. So it's not really a question whether it's an array or an NA. It's all the code and expectation that come with it. If we do SNAC, you require those devices to be SNAC, that means much more code in the device than just doing this. And I think that's the exact same answer for Gao earlier. What do we want and what do we expect from the other hand of this protocol?
I mean, yeah, just for SNAC, right? Like the ability to get addresses via Slack, right? And the ability to process arrays, that's in the node requirements. So if these are compliant v6 nodes, they have that code. They must have it, right? To the ability to receive arrays. Yeah. I mean, it's the same data structure, right? I mean, no, I mean, you sort of okay. I think my meta point is, you're there's a lot of forking that already happened, and there's more forking in the future. Yeah, and I think that's a problem that we ought to start fixing, because like the other thing is like, if you're talking about like classic v6 hosts implementing this stuff, it's a really high barrier to entry, right? I don't want to do ARO. I don't want to do any of this stuff, right? I've got implementations for all of this. I mean, ARO maybe is a special case because that's actually sort of very different, right? But all of this stuff, there's already protocols and implementations on hosts that do this. And why would we have two versions?
Yeah, so I think I'm next in queue, Eskodijk. So I also put some comments on the chat about this. So the forking that we mentioned happened already many years ago. So I think it's from 2014 RFC publication year of 6-loop on Andy. So, well, that's what you get when you fork. So separate protocol for 6-loop on networks. And then, yeah, that gets extended, of course. So I'm not sure why SNAC now keeps popping up, because SNAC is not designed for mesh networks in general. It's basically bridging something like a mesh network to your consumer's home network. That's typically what it's addressing now. So it's not a very generic at this moment, although we want to extend it, of course, in Snack.
Luigi, I think we are pretty late for this discussion, 12 years late. RFC 6775 has been published November 2012. There was a discussion. Yes, there was a fork. If we look at the Linux kernel, 6LoWPAN is a different stack, indeed. But this was a choice made 12 years ago. Now, starting to quibble about 6LoW prefix registration can be done in a different way. Sure. A lot of things that we discuss in this working group can be done in a different way. Okay, but there is a specific reason why 12 years ago there was a choice that has been made. If we want to revise that decision, let's do it, but it's not about the single documents. It's not about Snack. If we want to revise the decision, let's do it, but it's not about single documents. So discussing whether or not that document or the other document does the same thing like existing other documents, we are turning around here, in my opinion.
So Eric Vink, the AD again. So obviously we are running around. Water has gone under the bridge. I think you say in English. We will not come back in the past. Most probably we will do other things if we need to do 6LoW right now, but that's not the point. We can continue the discussion, right? I don't want to close, but not now. I think it's better over a beer or whatever at some point of time. We will not redo stuff. On the other hand, notably for the prefix thing, registration, I mean, you give array to any cache. So this one is slightly different. But for the address allocation, but what I really want, Pascal and Luigi, is that you say in a few words in the introduction, we describe this protocol because blah, 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 what you just said. That would, okay? We'll be cutting the discussion. Okay, that's it. You know.
Luigi, I was more thinking about a specific section in my case, but just to be clear, I don't want to wipe out the discussion of the specific solution. That there is things that have been said that are important and must be included. It's just a general observation that we can do the same things in another way. Is yes, but let's discuss in another side meeting, a beer, anything.
I will be joking now, right? Just to be clear. So Bob made some mistake in IPv6, right? It's not deployed. Can we work on IPv10? End of the joke.
Slightly less of a joke. I mean, I think, well, no, but it's still a joke, right? We made a decision to fork. We should continue. We should fork UDP. We should have 6LoW UDP. We should have 6LoW TCP, right? So that the question, it's not like, a fork is not a Boolean. Yes, it's a separate stack. Fortunately, hopefully that stops at the IP layer, right? So I think there's always a point where you should, when you fork, you should continue to ask yourself, can I get back, right? Because there's a cost to forking. So, we may be making the right decisions, but there ought to be some pressure to reuse stuff that we have, especially when that stuff is being standardized right now. And it's true that Snack is a bunch of stuff that is not needed here, right? But the core fact that you use an existing protocol format, an existing packet format to inform hosts of something, that's something that could have been done here, but it wasn't because, well, we already have our own way of doing things, right? So I think that's where it's a sort of, you just get into this groove and you just get further and further away. So I think it's good to keep thinking about this. And maybe these are all the right trade-offs, but somebody should always be saying, why do we need to fork? Or why do we continue to fork?
Okay, so yeah, probably we should continue this discussion, as the AD said, over some of the means. Perhaps it also means that maybe we should consider maybe a bit more time because the milestones we initially considered are quite early, but yeah. Anyway, perhaps we can even make it to the milestones even as they are. Let's see. And yeah, so maybe we may want to double check with the authors.
Being an author, Pascal, again, I mean, the comments are like continue or drop, but they are not impacting the document if we continue. So the decision may always be to drop, but if we don't, there is no reason from what I've seen the comments to change the dates.
So yeah, so basically the idea is that we can initiate a working group last call for these two documents, which are, well, Pascal document and Luigi, so the pass and the prefix registration. We can initiate the working group last call very soon. And then, okay, over that period, we may continue getting comments. We can even explicitly contact other people who might not have been following the discussions. And yeah, let's maybe keep the milestones initially as they are, and perhaps if necessary for whatever reason, we might update them later if needed.
If Luigi speaking, if to replace the question marks at the end of the slide, I mean, because of the discussion today, certainly we need a revision to be discussed here. So we will meet again. Here is 6 law, which means in Bangkok in March 2025, and then for the discussion. So tentatively, you can put the July 2026. Seems to me reasonable. 25. Sorry. I read July and thank you.
Okay, thank you. So I think for the other documents, the proposed dates are quite clear. And yeah, so these are the dates that we are going to consider and use as milestones initially. And I guess we can finish here this discussion about milestones, and now very quickly in 3 minutes at least present like the main ideas about the revision of the 6 Law Working Group Charter. So this charter was published in 2013. Perhaps it's still the original one. And since then, several things have happened. Related and relevant working groups have been created. Others have been closed. All of them which were mentioned in this charter. And also other things have evolved technically. So here is a set of 4 slides on red. Highlighted in red, there will be the changes that we are proposing. As you will see, these are minor changes. So in the first slide, there is nothing new that is suggested here. We believe that this still applies. We believe there's not time actually to read the whole thing. So these are the assumptions for 6 law networks. What does it mean to have a constrained node network? Which are the characteristics there? And in the second slide, there are some updates intended to mention some of the fundamental RFCs that have been created by the 6 law working group during these years. Also some update, which is that it appears that MIP modules is something which is kind of a little bit obsolete, perhaps. Then on the next slide, it's basically about the relation, coordination with the 6-man working group, which we understand should mostly continue the same. And only the minor detail that at the end of the slide, there was the mention of the LWIC working group, which has been closed. So now it should be removed from the charter. And the last one about relationship with other working groups, we believe that we should add now that work based on using SHIC header compression will be coordinated with the SHIC working group. This is actually happening already. So yeah, we believe it makes sense to include it explicitly. Also, yeah, a minor detail is that in the second bullet, you may see there's the third line, work related to routing is out of scope. We believe it would be a bit better to say work in routing is out of scope, because related to is perhaps too broad. 6LoWPAN defines a 6LBR, a 6LR, which are routers, right? And however, that doesn't mean that we are defining the routing performed by these devices. So this is one change we suggest. And finally, the core working group now belongs to the web and internet transport area. And there is now the IoT Ops working group, which is also related, which belongs to the Ops area, which didn't exist. The IoT Ops didn't exist at the time of the original charter. So yeah, we can probably send a link to these slides with the set of updates that we are suggesting, and maybe we can discuss on these updates on the mailing list, since we are almost done with the available time. I don't know if there's any quick comment from anyone. So as you can see, this is basically some minor update to the charter. Okay, so if there is no comments on this, then the session can end here, and see you all in Bangkok. And thanks a lot for all the contributions and presentations. Thank you very much. Yeah. Bye, Shweta.